Let's start. Chapter 6. Remember, this week we're trying to do 6A, 6B. Thank you. Shh. Listening. Thank you. Remember, we are in week 8. Next week is week 9. And week 10, you finish a bit early. From memory, it's a Tuesday. That's your formal last session. So really, I only have you on that Monday half session and the week 10. Remember the things that we need to do. We've got a quiz for chapter 4, which will happen next week in our half session. We also have a quiz for chapter 6 because all your reports are due on that Friday for me. It might even be published by that day too. Or maybe it's the next week, but I know that's the due date. So that's why we're doing 6A, 6B this week. That gives you time, so you do the quiz for chapter 4, and then whatever as a revision before, if you happen to be away, at least you have one session of revision before the quiz in week 10. Okay, it'll be a half session, and then I'll quickly mark that, or if we have time, you can mark it as well, and then I just do a bit of reporting based on your homework and what you've demonstrated. Okay? So the main skills are 6A and 6B. I mean, if in that week it looks good, I may teach you 6C and D together. I may not. I'm just focusing on the key skill is today's lesson, 6B. It's applying ratios to actually solve a problem. Okay, so yesterday's lesson, let's recap. What was exercise 6A about? Can I please have Ryan? What do you remember about 6A? What do we do? Very good. We did an intro to ratios. You needed to know how to, 1, write a ratio. So that was skill number 1. Very good. And the second skill is how to simplify a ratio. Both of which does not require you to apply. When do we use it? How do we use it? It's not in exercise 6A. Unless you do the problem-solving questions, then it will have some. 6B is where we apply. Okay, so that's why that's the important exercise to get you practicing. So here we go. Let's look at today's lesson. 6B, here we go. Solving ratio notes. Let's have a look here again. So in this example, I've got a block, okay, and that could represent anything. That block could represent lottery money. It could represent the cost to invest into a share. These are the dividends, okay? This could represent the mixture for a cookie recipe. This is the ratio, okay? So 1 to 3 could be anything. It could be, in terms of cooking, could be 1 cup of water to 3 cups sugar. It could be for every 1 male, there are 3 females. The ratio, we don't know what those quantities represent. Okay? First part is, if you have a 1 to 3 ratio, let's recap yesterday. How many parts, total parts, are there if it's a 1 to 3 ratio? Let's go, Jacob. 4, very good. So there's a diagram here to help you visualize it. But what I was trying to teach you yesterday was if you have 1 part for something and then 3 parts for another, in total, it's 1 plus 3 gives you a total of 4 parts. Visually, you can see it here. If this was water versus sugar, then we can see 1 part is water and then 3 parts are sugar. So in total, 1 plus 3 gives you a total of 4. 4 parts in total. Okay? And I emphasize this diagram because when you're starting to do problem solving, the diagram can help you visualize what's happening. So how many parts? You would write 4. 4 should go here. So a total of 4 parts. That means the ratio of 1 to 3, if it was water and sugar, 1 part water to 3 parts sugar, what it actually truly means is in this total recipe, 1 out of 4 is water. So can you see that language that I'm using? Because it's a total of 4 to make this recipe, I know out of the 4 parts, only 1 out of 4. Ooh, what's going on there? It's funny. Huh? Oh, there we go. 1 out of 4 and 3 out of 4 is what the 1-to-3 ratio means. So 1/4, if it was water, then it's 1/4 water, 3/4 sugar. So I'm trying to teach you how to relate ratios to fractions when you're interpreting it. So 1-to-3 ratio means this number 1 is going to be 1/4 of the total. And that's going to be 3/4 of the total. Here's the method. If you didn't understand what I was trying to explain, then you can memorize the steps here. The method is, first, calculate the total number of parts. And then number 2, multiply the fraction to the total. And that will give you the actual quantity. Here's an example so that you can understand what I'm trying to say there. Here's an example. Example number 1. You've got 30 meters. So imagine a 30-meter track. Okay, so I'm going to draw the diagram. Imagine this is your track. 30 meters. So the entire thing is 30 meters. But let's say if this track, 2 parts is actually 2 parts. Let me do it equally. 2 parts is actually sand. And then only the other 3 parts, 1, 2, 3, is the road where you can run. Okay, so 2 to 3. So out of that total track, 30 meters, 2 parts you can't run on. Sand, you don't run on that. You walk through it and then you run the 3 parts. That could represent what a 2 to 3 could mean. Okay, so this is 2 parts of the 30. This is 3 parts of the 30. If we're asking now, what is the total number of parts? What is the answer to the total number of parts here? Can I please have Nick?
The total number of parts, 5.
5, very good. So we can see that there are 5 parts, and I've drawn the diagram to help you visualize it. 2 parts is this section, and then another 3 parts equally. That gives you a total of 5. Now, out of those 5 parts, we know if I said this scenario was this is sand and you can't run on it, then we know it's 2 out of 5 parts. So 2 out of 5 parts is sand and you can't run on it. But then 3 out of 5 parts you can. But you see, when someone asks you, it's like, oh, where can I run? You don't say you can run 2/5 of it and then 3/5 you can't. A lot of people don't understand that. So you got to change that language to meters, or in reference to this case, how long of a track can you run and where can't you run? So here, this is how we work it out. So step number 1, remember method 1 was find total number of parts. So here's number 1. Number 2, well, let's calculate it. What is a 2 to 3 ratio actually look like in terms of the length? Because we're talking about 30 meters. So out of 30 meters, I want to find how much of it is sand that I can't run on. So 2/5 of 30, when you say 2/5 of the total, of means times. You're just calculating what 2/5 times 30 is. Now at this point, if you don't know how to do the fractions, it's okay. You can learn how to practice on the calculator, because I'm trying to teach you how to think and how to solve, right? If you don't know how to do this by hand, that's okay. I want you to practice with a calculator. So if you were to type this on a calculator, what would it look like? Let's read it. When you say 2/5, what's this symbol mean again? What's the over mean? Charlie? What's the symbol mean? Divide. So on your calculator, this actually just means 2 divide 5. That's what the fraction means. 2/5 just means 2 divide 5. And then of, that's the word of. Of means times. So on your calculator, you press times 30. So if I do that on a calculator right now for you to see, so here we go. 2 divide 5 is 0.4, and then I times that by 30. That tells me 12. What does that mean when you say 12? This 12 means that out of the 30 meters, 12 meters you can't run. That's what it means. Yeah, 12 meters is the 2 parts. This here is easier for people to understand when you say, you can't run to that 12-meter part, but for the next whatever part in terms of meters, then you can run. Okay, so you could say 12 meters is sand, so you can't run on it. People understand that. Then you go to the next one. Well, let's work out how much can you actually run on then. Let's do it again. Let's read this one. What would you type on the calculator if you want to work out the ratio of 2 to 3 of a 30-meter length? 3/5 of 30. 3/5 of 30. What would you type on the calculator? Can I please have, let's go with Attila. Beautiful. So on your calculator, 3/5 just means 3 divide 5. Of means times. 3 divided by 5 times 30. Now if we do this, now logically you can probably also figure it out. Ready? If 30 meters is the length and 12 of it you can't run, well then the leftover must be the amount that you can run. So surely it must be 18. But just in case you didn't realize that, we can actually calculate it as well. Let's do it. 3 divide 5, then times by 30. See how it's 18? Makes sense. Why is it 18 meters? Well, if you think about the diagram again. So the diagram, 2 parts was sand, 3 parts was road. You just worked out this is 12, and you knew that the path was 30 meters. So of course the leftover, 30 take away 12, must give you the leftover. So it must mean it's 18. So there's multiple ways of working it out. But can you see the mathematics that I'm showing you? You either know how to do it by hand, 3/5 times 30, using fraction skills, or knowing how to use a calculator to problem solve. Either way, I expect you to be able to solve the problem, regardless. Okay? So 2 steps. Find the total number of parts, then work out that as a fraction of the total. Okay, let's do another one. Flip over the page. Flip over the page. Let's do another one. Let's take this scenario. Let's say 3 students in this class chipped in to buy a lottery ticket. Let's say, Nick, you put in $1. Xavier, you put in $2. And Attila puts in $2. How much was the ticket worth to buy this ticket? How much did they chip in together in total? 5. So together, $5 to buy this lottery ticket. Remember, Nick puts in $1, Xavier puts in 2, and Attila puts in 2. So together it's $5 to buy a ticket. Let's say they got lucky, and the raffle ticket says that they won $200. Yeah, that's pretty nice. Now, they got to divvy it up between each other. So this block of $200, think of it as a full block. 1 part is Nick, because Nick contributed 1 part. Whereas Xavier contributed 2 equal parts. So he should get more of the money of the prize than Nick. And Attila contributed 2 parts as well. So that means whatever Xavier's going to get in total, Attila should get the same amount. So the question is how much? So when you guys divvy it up, you can solve this problem by following the 2 steps. Find the total number of parts. So again, what's the total number of parts here? 5, very good. So 1 plus 2 plus 2, 5 total parts, which you can count in the diagram. Therefore, in terms of fractions, Nick should get 1 out of 5 parts of the total amount. Xavier should get 2 out of 5 parts of the total amount. And Attila gets 2/5 of the total amount. So that means, to work out for Nick, it's 1/5 times 200. Whereas Xavier is 2/5 times 200. And Attila is the same, 2/5 times 200. Again, you can practice doing fractions, or you can do it on a calculator. The point is, I want you to be able to think how to solve it. So here we go. If you type on a calculator, 1/5 is the same as 1 divide 5 times 200. Here we go. I'm going to do it a calculator. 1 divide 5 times 200. He gets $40. Nick gets $40, which is still great. He invested $1 and he gets $40. But you can see that Xavier should get more than that. He gets 2 parts, so technically double whatever Nick gets. But again, you can prove it. We know it's going to be 80, but we can prove it. 2 divided by 5 times 200. So 2 divide 5 times 200. Let's see. 2 divide 5, so 2 over 5. Of means times 200. And it is true. Xavier does get double because he invested double the amount. So he should get $80. And we know that Tilla should also get the same amount. So Tilla should get $80 as well. And together, does it add up to the $200 prize? 40 plus 80 plus 80. Yes, it does. 80 plus 80 is 160. 160 with the extra 40 does make sense. That is the application to using ratios. Now, if you did want to do it by hand, thank you, copying notes. This is the fraction skill, so 2 over 5 times 200. Now 200 is a whole number. You got to write it as a fraction in order to do fraction skills. How do you write 200 as a fraction?
200 over 1.
200 over 1. Okay, because that's how many ones in 200? There's 200 of them, so 200 over 1. When you multiply, it's usually top with top, bottom and bottom. But we can simplify where we can see to make the fraction easier. Now I can already see 2 numbers that have a common factor. Which 2 numbers have a common factor that I can simplify?
205.
205. So 5 and 200, they both have a common factor. And they both have a common factor of 5. So 5 fits into 5 and 5 also fits in 200. So again, like I said, if your multiples and fraction skills aren't strong, this doesn't have to be the only method. It's just a suggestion if you want to use it. So 5 goes into 5 once. How many 5s fit in 200? 40. So this is what you get. You get 2 over 1 times 40 over 1. We've simplified the fraction. Now when we times them, top with top, bottom with bottom, 2 times 40 is 80. And 80 over 1 times 1, which is 1, gives you $80 as well. So there's 2 ways to do it there. 2 ways, as you can see. So calculator, fraction skills. Regardless, I just need to know that you can problem solve. Last example, I'm going to give you, let's time it, maybe give you 4 minutes. I want you to answer this last question. So the scenario is you got ratio of boys to girls. So the school has 4 to 5 ratio. Okay? So it's a 4 to 5 ratio and that's boys to girls. So boys is 4. So every 4 boys, there are 5 girls. They're saying if there are 240 boys, how many students are there in total? Okay, so it's 4 to 5. You know it's 240 boys. The question is, what is the total? So a bit of problem solving. So you know the school is a 4 to 5 ratio. You currently know that in the school there's 240 boys. What's the total number of parts? Which means, how many students are there at the school? 4 minutes. It's 12:36. At 12:40 we'll look at the answer. And that's it for today's lesson. Okay, so it's about applying ratios, seeing if you can think and problem solve. So 6A was theory, 6A was simplifying. Here we're trying to problem solve. That's your answer. 540. I'm going to stop the video.